Let's take a look at the questions on homework 13. We'll start with determining if a graph is a function. In order to determine if a graph is a function, you'll need to use something called the vertical line test. And that's where you take your pen or pencil, you hold it up vertically, which looks like this, and you take this vertical line and you move it along the graph from left to right, if I was moving it and going down. And what you're looking to see is if as you move this line along the graph, if you touch the graph in more than one location, like here and here at the same time, then you fail the vertical line test. And if you fail the vertical line test, then you are not a function. So we're going to click not a function here at the bottom. And when I submit, you'll see a little animation show up. See that green vertical line? See, as it scans, it does touch the function in more than one location. So this is not a function. This is not a function. All right, let's take a look at another question. Okay, again, I'm going to hold my pen or pencil up along the screen, and I'm going to take it and slide it down. And you'll notice my vertical purple line never touches that black curve in two locations at the same time. So this one is a function. This one is a function. So we'll choose function and we'll click submit. All right, let's go back and take a look at the second topic. Identify linear functions from points. Now this is different than the graph. The graph, you use a vertical line test. But with tables or points, you're looking for something known as a constant rate of change, also known as a slope. So a constant slope, or the same ratio every time. Remember the ratio, the pattern of the y's over the pattern of the x's. So let's take a quick look here. You can look to see how these numbers are changing. It looks like this one is increasing by 3, by 3, by 3, so that's looking good. But now we have to check the pattern of our x's. Is that also constant? This one's increasing by 4, this one's increasing by 4, but this one's only increasing by 3. So my first ratio was 3 over 4, my second ratio was 3 over 4, but my last ratio was 3 over 3. That is not constant. So letter A is not a linear function. Let's take a look at B. This one appears to be growing at 2 plus 2, and this one is plus 5. Okay, this one is plus 1. This one here is plus 1. So far we've got 2 over 1, we've got 2 over 1 again, and now this one is 5 over 3. Not constant. So A and B are not linear. Let's take a look at letter C. This one seems to be increasing by 4. This one is increasing by 2. This one is increasing also by 2. Let's take a look at the other side here. This one looks like it's going up 6. This one's going up 3. And this one's also going up by 3. Now let's take a look at those ratios. 4 over 6, 2 over 3, and 2 over 3. Now I do realize that this one looks different, but if you simplify or reduce this fraction, it would also be 2 over 3. So all of them are constantly the same. So that makes C our linear function. All right, let's take a look at one more. Again, you're looking for a linear function. You're looking for a linear function. So we are looking for, first of all, no x's repeating. We want to be a function. So we scan all these x's. Make sure we don't have any repeats. Good. So these are all functions. The next thing we're looking for is for it to be linear, for the pattern to be the same. So this right here is kind of like having a table. -6, 0, -3, 3, 0, 6, 3, 9. So I'm looking at that pattern, +3, +3, +3, +3, +3, +3. So this does have a constant pattern. Now we'll take a look at the second one just to show you that this one does not have a constant pattern. So we had -6 with 5, -3 with 2, 0, -2, and 3, -5. So this one went down 3, but this one went down 4, and this one went down 3. This one went up 3, up 3, up 3. 3 over 3, 4 over 3, 3 over 3. It's not the same. So you can see that A works and B does not. And you can do that by just taking the choices, setting it up in a table of your own. 2, 4, 5, 7, 8, 4, 0, -8. And just really looking at that pattern. Just really look to see the change of that pattern and how it's not constant. So we're going to select A, and we're going to go back to the next topic. Alright, next topic here is graphing lines from equations. Now we've been doing this for several weeks now, so let's see how you do. First thing you need to do is you need to plot your y-intercept. After that, you follow the slope. If you don't see the slope, the number's an invisible 1. So again, I'm going to plot at -4 first, and then I'm going to move rise 1, run 1. And there's my line. Again, you have to use the equation in order to graph your line. Y-intercept is first, and then rise and run is second. Rise 2, run 5. So you're going to click on your graph in those two locations. -6, and then rise 2, run 5. Submit, and check. Let's go back to the next topic, comparing rates for linear representations. So this one you have to be a careful reader. It asks you which one has the same rate as this equation. Notice I am circling the rate value. The rate value is always the coefficient of x. That's the rate of change. So 7/4 is the rate of change, also known as 1.75. I know that by taking 7 and dividing it by 4. So I'm looking for something that has the same rate as 7/4. The same rate as 7/4. So let's take a look at what we've got so far. Alright, so 7/4. You see how this one is going downhill? So I know that it's wrong. You can't have a positive slope if you're going downhill. And now I'm going to check this one because it's pretty fast. It's definitely not going up 7 and over 4. So I know both of these are out. So now I have to look at the pattern here. This looks like it's going down 4 and up 4. So this has a slope or rate of change of -1, so that's out. And it looks like this one goes up 7, up 4, and that's my winner. That's the one that has the same slope. So we'll choose C, and we'll try another question. Here's a graph, and we want something that has a lesser or smaller rate of change. Well, first I need to find the rate of change for that graph. Let me zoom in and find what I call perfect corner points. So I see one here, and I see one here, I see one here. So it looks like it's down 2 over 1, down 2 over 1. So my slope is -2. I'm looking for something that has a slope that's lesser than this, or smaller than this. So let's take a look at the easiest ones first. Let's take a look at the equations. Because to be lesser means all I have to do is look at these coefficient numbers. 6 is higher, but -6 is lesser. So I know my answer is B. All right, let's take a look at our next topic. Let's see. Changing a table to a linear equation. All right, the table can give you the values for this linear equation because this is the y-intercept, which is the number when x is 0. And this is the rate of change, or the pattern of the y's and the pattern of the x's. And both of those can be seen in the table. Let's start over here with the y-intercept. That's the easiest one to find, because if you see an x with a 0, then you found the y-intercept. So right now, my sentence is going to have a -2 after the x. All we need to do now is erase and replace the slope letter m. How do I do that? I do that by looking at the rate of change. So I'm looking to find the pattern of the y's and the pattern of the x's. The pattern of the y looks to be going up 8. The pattern of the x's looks to be going up 1. That's 8 over 1. So that means the equation of the line is 8x minus 2. Type that here in the box and click Submit. Let's do this again. All right, I'm looking for my rate of change and I'm looking for my y-intercept. The y-intercept can be found in the table with your eyes. So for us, our y-intercept is -9. So I don't need this plus sign because the 9 is negative. Next, I'm going to find the pattern of my table. The pattern of the y's goes on top, so I like to start there. That is the top of my fraction. So this looks like it's increasing by 2. And the x's are increasing by 1. That means that my m value is 2. So my sentence will be 2x minus 9. Right here, 2x minus 9. One last time. Look in the table for the y-intercept. Look at the patterns to find your m. So that's your b, this is your m. Don't forget the y value goes in the numerator. So if this goes up 7, and this goes up 1, then your slope is 7. If 0 is paired with 5, then your y-intercept is 5. All right, let's take a look at the last lesson, which is linear tables to linear equations. So this one is similar to the last one, except there are no 0 values. Wah, wah, wah. So unfortunately, that means we're going to have to do a little bit of work. The first thing we need to do is find our slope. So that's something we can find from the table. Now, if you can't mentally find the pattern yourself, you just pick any 2 points you want, and you use that giant subtraction fraction, y minus y over x minus x. So it looks like our slope number is going to be 10 over 5, also known as 2. Now, we want a slope-intercept form equation, but we need to know these two numbers. We only know this one. So let's substitute in here for the letter m what we know, which is that the slope is 2. Now in order to find out what b is, we need x and y to go away. So what we're going to do is we're going to erase and replace the letters x and y with any x and y from the table. I choose this one. So x is 2, that goes here. Y is 0, that goes there. So 0 is equal to 4 plus b, and when I get b by itself, I see that b is -4. Now don't forget, when you write your answer, you only need 2 letters, m and b. There's m, and there's b. Took a lot of work to get there, but we found it. Y equals 2x minus 4. Let's try this one more time. First thing you need to do is find your slope. Sometimes you can find it pretty quickly just using your mental math. 4 to 6 is adding 2, and 1 to 3 is also adding 2. So my slope number is 2 over 2, also known as 1. I'm going to use my slope-intercept equation. I'm going to erase and replace my slope number with the number 1. Now I need to pick one x and y point. I'm going to pick this one. So I'm going to replace my letter y with y. Y happens to be the 8. Now I'm going to erase my letter x and replace it with the x value, which was 5. So when I multiply, 1 times 5, and then when I solve, I get b is 3. So now I know my two numbers. Y equals 1x plus 3. Now I'm going to leave that 1 invisible. Y equals x plus 3. And that's how you write a slope-intercept equation from a table. Good luck.